weekend review for C++, and then we'll also talk about next week's agenda. So interesting, we talked about decimals or double, and we highlighted how troublesome working with decimals can be in a programming language. And we had some test cases to show that comparing decimals is uh, not a good idea. So then in that case, we must convert them to whole numbers and then compare whole numbers on both sides, which will give us better test results. We talked about the auto keyword and how auto tells the compiler, hey, you figure out the data type that I'm working with depending on what values I assign to the variables. And then we talked about character and string types. On that note, we were shown how values that are in variables are in our diagrammed in memory. We have the stack memory right here. On the left side, we have auto num equals 10, meaning num is an integer. On the stack, this is what we would see. We would see a block of memory for the main function on the stack. We would see 4 bytes of memory allocated for the num variable. And if we had superhuman vision to look into the computer, then more than likely we would see something like this. Okay. In our class, this is how we will draw stack numbers here at the bottom. It's simply that we'll be working with the numerical values, which is easier at the moment for us to work with, right? We also were shown how the letter for a character is stored in memory. So the letter J is represented by the number 74, and this is a binary value in memory, and it's only 1 byte. And the values on the stack. And we were also shown how the string is on the stack, right? So how is it on the stack? Well, we have the heap memory, and the values for the name variable are on the heap. JOHN right here on the heap or free store. And the stack keeps track of that by, instead of having the value John here, having the address where John begins stored. So then there's complicated code behind the scenes that the string class has that knows how to make this happen and how to retrieve values from the string class. Okay. We also went into a deep dive of how C++ handles working with integers and doubles, double being decimal, integer being whole number. And we have some rules that we went over, how integers are converted to double automatically and how doubles are converted to integers automatically in C++. We went through some of those examples for you all. And we also talked about operator precedence. I think that was before this, but we covered operator precedence just to show that C++, like most programming languages, follow the math operator precedence, meaning like parentheses first and what have you. We talked about explicit conversion of one data type to another, and we use the static cast keyword for that. And we went over a simple example just to show you how we can convert a number. We talked about the concept of overflow and underflow, and we talked about an integer. And the largest number an integer could have, plus 1, will cause problems in C++. So this on the stack memory right here, so this is stack memory. Notice that all the bytes of 4 bytes are full. So if we add one more number, then we get an overflow. meaning there's not enough there's not enough bits to represent a number higher than the one on the screen. And we also went and talked about underflow, which is the opposite, like how low or how close can we get to zero with decimals. And we also found out that that would cause an underflow if we're working with a decimal that's very close to zero, and then we divide that by, say, the number 10, and then we would get a result of zero because the compiler does not cannot handle that situation, right? So we need to be careful with those situations. And then we went over a constant example, and I just want to briefly just make sure I bring that one up because this one will come back and module 2 constants, right? So one thing I recommended was create a constant outside the functions in the constants.header or in the header file. That way it's accessible to your functions in that header file. That's the concept of a global variable, but it's kind of like we've kind of minimized it a little bit, but not quite. But now notice we can use that in our functions. We don't have to be constantly declaring that constant in the functions. And then we're going to leave this for next class, which brings up the readings for next week. Well, actually, before the readings, let's go over homework 1. So actually homework 2, right? I'll relabel it homework 2. So we have some homework. So we're gonna create a simple restaurant bill receipt. We will write a program that displays a receipt with meal amount, sales tax, tip, and total amount. We will capture the meal amount and tip percentage from the keyboard. Okay, we're assuming that the tax rate is 6.75, meaning this is a good candidate for a constant variable. We have test functions. Okay, let me see here. Okay, so we write get sales tax amount and get tip amount because we want to make our code testable. And then we have some instructions here, high level. So for the get sales tax amount, it has one parameter meal amount, and then we will declare a const double tax rate with value 6.75. Hence that example that I talked about previously in this video. Make sure you go back and refer to it to complete this assignment. And in the function, we simply return the product of meal amount and tax rate. And then for tip amount, we return, we have two parameters, meal amount and tip rate, and we simply return their product, okay? And then I always guide you, right? So make sure you write that function prototypes and or the signature in the .h file, and you write the function code in the CPP file. What is that? Briefly, like this is the function code. And if we look at the header, then this is the function header, signature, or prototype, okay? So that's the convention you need to follow. Okay, for unit tests, I give you data that you need to use for your required assertions in your test cases, okay? So just follow these instructions here and make sure that your functions are green. And after you do that, then you can come in here to the main program. And then I ask you to capture data from the keyboard, create some variables, call the get sales tax amount function and the get tip amount. And finally, you produce output like this to your screen. At this moment, I'm not concerned about right justification or anything like that. So don't worry about that, okay? And then after you're done, then you simply submit your assignment. Make sure you put your GitHub username. So we have bring up the menu, come up here, and let's go and what's on deck for next week. So we scroll down here, And we will be talking about this one. Can be placed on hold for right now, so I'll make it unavailable. We'll talk about decisions. So we'll talk about the concept of a Boolean variable and where it came from. We'll talk about conditional structures if else, if, and we'll talk about a conditional operator shortcut. We'll introduce the logical operators and, or, and not. We'll talk about a switch statement, and then we'll talk about enumerations and what those are. So we click here, we go to readings, and make sure you read chapter 4, sections 1 through 13 on the Gaddis, and on the free Fundamentals of C++ book, then read chapter 5. Okay, so this will give you a good idea of what we're going to cover next week. And again, look forward to more learning next week, and hopefully this video is helpful for you.